Welcome back. Today we're moving on to learning about fractions, starting with equivalent fractions. Have a go at these get ready questions. A non-unit fraction is where the numerator is greater than 1. So 2/5, 4/5 and 5/6 are all non-unit fractions. Question 2. 2 out of the 5 equal parts are shaded, so that's 2/5. And question 3, 4 out of the 10 equal parts are shaded, so that's 4/10. What do you notice about the amount shaded in question 2 and 3? Today we're going to be looking at equivalent fractions, but first let's look at the word equivalent. What's important to know is that equivalent doesn't necessarily mean the same, as in a mirror image of it. It means having the same value or amount. So for example, 2 1p coins are equivalent to 2p. Although they don't look the same, they have the same value. Similarly, 10 lots of 1/100ths is equivalent to 1/10. They look different, but they have the same value. Let's get started looking at fractions. I have a strip of paper and I'm going to cut it into 2 equal pieces. So we can divide it into 2 pieces. Now I'm going to get the same size strip of paper, but this time I'm going to cut it into 4 equal pieces. You might want to have a go at this yourselves. You can see I have 4 equal parts. Pause the video here. What do you notice? Let's see. We have those 2 strips of paper, and the top one, we can see we've divided it into 2 equal parts. So each part is worth a half. And then the second strip of paper, we've got 4 equal parts. So each part is worth a quarter, or 1 out of 4 equal parts. One thing you may have noticed was that 1/2 was the same size as 2 quarters. So a half is equivalent to 2 quarters. Let's look at the relationships. I notice that the denominator is twice the size of the numerator. And it's the same for 2 quarters. If I double the numerator, I get the denominator. I can think of it the other way round as well. I notice that the numerator is half the size of the denominator, so I can divide the denominator by 2 to get the numerator. Here we have a number line from 0 to 1, with each interval worth a quarter. I'm also going to get a strip of paper and divide it into 8 equal parts. The number line and paper must be the same length as they have the same hole, 1. Do you notice anything so far? One thing we can see is that 2 out of these 8 parts are equivalent to a quarter, as they're the same size. What if we divided our strip of paper into 20 equal parts? How many 20ths are equivalent to a quarter? That's right, 5 20ths are equivalent to 1 quarter. We can also see the same relationship in 3/12. 3 out of the 12 equal parts is equivalent to 1 quarter. All of these fractions are equivalent in size. Okay then. So we have some fractions here, and we need to find the missing boxes. Pause the video and have a think for yourself first. Let's have a look. 1 quarter is equivalent to 2/8. Then we should have 3/12 and 5 20ths. Now with this final one, we could have lots of different options here. Maybe you put 4/16 or 10/40. There's many options. But now let's look at what's actually happened here. So we have a list of equivalent fractions now. Pause the video and have a think. What do you notice about all these fractions? You may have noticed the relationship between the numerator and denominator. I can see that if I multiply the numerator by 4, I get the denominator. Or similarly, if I divide the denominator by 4, it gives me the numerator. I also notice that when looking at 1/4 and 2/8, I multiplied both the numerator and denominator by 2. For 3/12, I multiplied both by 3. For 5/20, I multiplied both the numerator and denominator by 5. And for 10/40, I multiplied both by 10. Let's have a look at this one. Now it's slightly different as we're not looking at unit fractions anymore. We're looking at a non-unit fraction because the numerator is greater than 1. So 3/4 is equal to 12 somethings. I can see this relationship here, that 12 is 4 times greater than 3. So to maintain that same relationship, I must multiply the denominator by 4 as well. So 4 multiplied by 4 is equal to 16. So 3/4 is equivalent to 12/16. And looking at this using a bar model, I can see I've got 3/4. And here is the same 3/4. But if we want to represent 12/16, we can divide each of the quarters into 4 parts. Now we can see that 3/4 is equivalent to 12/16. Now it's your turn. Pause the video and have a go at finding the missing boxes. How did you get on? We can see when looking at the denominators on the first one that 12 is 3 times greater than 4. So in order to keep that relationship the same, we need to do the same to the numerator. 3 multiplied by 3 is equal to 9. So 3/4 is equivalent to 9/12. For the bottom one, it's the other way round. I can see that 5 is 3 times smaller than 15, so I've divided by 3, which means I must do the same to the numerator. 9 divided by 3 is equal to 3, so 3/5 is equivalent to 9/15. Pause the video and have a go at questions 1 to 4 on the worksheet. Hi there, Tiny. Tiny says 2/3 is equivalent to 8/9 because they added 6 to both the numerator and denominator. Pause the video and have a think. Is Tiny correct? And can you use a diagram to support your answer? So I can show 2/3 on a bar model. And here's the same 2/3. I want to represent 9ths, so I can divide each of the thirds into 3 parts. Now I can see straight away Tiny's incorrect. 9 is 3 times greater than 3. So we've multiplied the denominator by 3. And in order to maintain that relationship, we must also multiply the numerator by 3. So 2/3 is equivalent to 6/9. Let's look at this final problem together. We need to find the missing boxes to make these fractions equivalent. We have 12/15. Now what have I multiplied 12 by to get to 40? It's certainly not a whole number, so that's going to be quite tricky. Let's look at our other fractions. I can see I have divided the denominator 15 by 3 to get 5. So to find this numerator, I must divide 12 by 3. So 12/15 is equivalent to 4/5. Oh, and now I can see a relationship between the numerator 4 and 40. 40 is 10 times greater than 4. So to maintain the relationship, I must multiply 5 by 10. So 12/15, 40/50, and 4/5 are all equivalent. Pause the video and have a go at the rest of the questions on the worksheet.